Let's take a look at how special log 10 can be and get some practice with calculators. First, though, let's look at some really common logarithms, some things that we can do in our heads. Log base 7 of 7, log base 3 of 3, log base 24 of 24, log base Clifford of Clifford, or log base dog of your dog. These all have the same answers. They're all equal to 1 because 7 to the first power is 7, 3 to the first power is 3, 24 to the first power is 24, and your dog to the first power is your dog. So log base dog of your dog is 1. That pattern always holds. Here's some other special ones. Log base 7 of 1, log base 3 of 1, log base 24 of 1, log base Clifford of 1. These all have the same answers. They're all 0. Remember, the output of a logarithm is an exponent. 7 to the 0 power is 1. 3 to the 0 power is 1. 24 to the 0 power is 1. And Clifford to the 0 power is 1. But here's a problem. 1 to the 0 power is 1. 1 to the first power is 1. 1 to the second power is 1. 1 to any power is 1. Well, here's how we take care of that. You can never use 1 as the base of a logarithm, ever. You're not allowed to do it. Any other positive number can go there. These numbers are always positive, and these numbers here are always positive. We can get negative answers on the right-hand side because, of course, those are exponents, and they may cause us to need a reciprocal or to go across the fraction bar. Now let's get to how special 10 is. It's probably the easiest base to have for logarithms. Log base 10 of 1,000 is 3 because 10 to the third power is 1,000, 3 zeros. Log base 10 of 100 is 2 because 10 to the second power is 100, 2 zeros. Log base 10 of 10 is 1, we just covered that, and 10 to the first power is 10. Log base 10 of 1 is 0, we just covered that, because 10 to the 0 power is 1. And then when we have negative exponents, 10 to the negative first power is 1/10, or 0.1. 10 to the negative 2 power is 1 over 100, so log base 10 of 1 over 100 is negative 2. It all deals with continually moving that decimal point from 1,000 over to 100 to 10 to 1, etc. You've probably learned that in covering scientific notation in some of your classes. Well, it's so special as a base, we don't even write 10 as a base. If you don't see a base for a logarithm, then the base is 10. So notice this just says log of 1,000. It's understood that the base is 10. There are two numbers that are very, very special for bases. One of them is 10, and believe it or not, another one is about 2.71828. We'll discuss that at a later time. Exponential graphs can be very useful. These graphs here use powers of 10 because there are numbers that are really, really small and numbers that are really, really big. In 2020, COVID-19 hit the world, and these graphs here are trying to indicate the cumulative number of cases that different states in the United States had compared to New York, which is in gray. The other states are in an orange, brownish color since the 10th confirmed case. But you see the numbers get pretty high when you're accumulating the data. New York starts at 10 and ends up way over 100,000. So it would be very difficult to try to graph these things. Sorry, this text didn't fit into the screen. It's difficult to fit numbers that range from 10 to 100,000 is what this says on a line graph. If you were to try to take a bar graph and started counting by tens, you'd have to go way beyond your paper to try to get to 100,000. So in these graphs, what we have is 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power, 10 to the fifth power, 10 to the sixth power. So you're not going up by the same amount every time, but you're going up by the same power every time on all of these graphs. When USA Today put this out, they had all 50 states. So even online, you're still trying to get the graphs to fit. So it's not the same distance. It's going up 90 here, up 900. But I mean, you're going up by powers of 10 though. And that allows the graphs to fit. We'll see that with some other things later on as well, such as measuring sound and pH level. So that's an advantage that logarithms and exponents can have when we're trying to graph both very small and very large numbers, and we need them to fit on one graph. Log base 10 is so important, it's programmed into your scientific calculators. If you look, there is a button somewhere that says log, whether your scientific calculator is on a phone or an actual calculator. So let's find log of 345. Remember, it's understood that the base is 10. So we know it's between 2 and 3 because 10 squared is 100 and 10 to the third power is 1,000. So it's got to be somewhere between 2 and 3, but who knows where. If you have a text-based calculator, you're going to press the log button first, then type in 345, and then press enter or equals. So on something like this TI-30, it's a text-based calculator because if you press the log button, the word log shows up on the screen up in here. So a close-up of this shows where you'll find the log button. It's there. You would press this log button first, then enter in 345, and then press the equals button, and you should get to 3 decimal places 2.538. But if you have a calculator that's not text-based, you're going to enter the 345 first, then press the log button, and then press enter. So this example of a calculator, here's the 345, then we're going to have to press log. Once we press this log button, then the screen would change to the 2.538. Take a moment and practice that with whatever calculator you have and see what it takes to make it work, all right? Feel free to pause the video. Try another one. Find log of 6,742 on your calculator. Go ahead and pause the video. You should get to 3 decimal places 3.829. We can go backwards as well. If we're trying to find log x of something, remember, we know that base is 10. So if we're trying to solve log x equals 2.592, well, that's the same thing as log base 10 of x equals 2.592. And when we write that exponentially, that's 10 to the 2.592 power equals x. So you could use your exponent button, which may look like this. We're going to cover that again in a moment, or your x to the y button. But you may also have this 10 to the x button or a feature like this. In fact, it may be the second or shift feature of your log button. The answer to this problem is 390.841 to 3 decimal places. So on a TI-30, you'll see this 10 to the x is the second function or the inverse function of the log button. So to make this show up, you have to press the blue second, then this button, and you'll get 10 to the x to show up here. Then you can type in 2.592 and press enter, and you'll get this answer. If you have a non-text-based calculator, you would need to put in, if you have a 10 to the x feature, you would need to put the 2.592 in first, then get that 10 to x pressed, and then you'll get the answer. Alternatively, you could also just do 10, type in the number 10, press this exponent, and then 2.592 and press enter. But go ahead and pause the video and give that a try to see if you can make that 10 to the x feature work. It's probably the quickest way to solve this, because you just see this equation and know, oh, 10 to the x equals 2.592. Give that a try and see what it takes to get 390.841. Exponents. Look for that caret button or an x to the y button or a y to the x button. Let's try one that's pretty easy. 2 to the 5th power. That answer is 32. You may have to put the 2 in first and then press the exponent button and the 5. Maybe you have a calculator where you have to put the 5 in first. So practice this and make sure you know how to use your exponent buttons. Feel free to pause the video. We also want to make sure you can find roots. So you're probably looking for something that has a variable outside of a radical house. There might be another variable in the inside or not. On this TI-30, it's a second feature of the exponent button, that caret. You see this x and then a radical. It doesn't have anything on the inside. So you would, on a TI-30, put the root in first, then get this feature, and then put what was inside the radical house second. You might have to go the other way on different calculators. So let's wrap up this calculator practice with one that has an easy answer, but we want you to practice with your calculator to find it. The 5th root of 243. The answer to that is 3. So see how you can use your root button. Figure out if you have to do the 5 first, then press the root button, then 243, and then enter. Or do you put the 243 in first, then press the button, and then press 5? Or whatever order it takes. Some of your calculators, you may not even have to press enter or equals to get the answer. Be sure to ask questions if you have them.